So, welcome to Glasgow and to Francesco being here with me from Miniswys.
Very nice being here, this time from this side of the live.
It's your first time live, I guess.
Correct, correct. We were quite secretive until last week.
Yeah. And the camera
Yes.
is, by the way, there. Yeah. We always look up there because there's Dave.
Indeed, Francesco. Your department, your Miniswys were like the Q department in the Bond film. They made all the cool gadgets, but nobody knew who they were.
Correct.
Do we have an okay sound? Arthur is here. Arthur and the camera
Yes.
is, by the way, there. Yeah. We always look up there because there's Dave. Wait. I have double sound. No, it just detected it because we had 10 seconds delay and I switched off the stream.
There we go. Yep. So I've got a copy of the stream going right. So welcome everyone as well. So we're going to obviously do a Q&A session on this. So we've got lots and lots of questions have come in about MicroReg, about Quest Zero, and of course about the Revolution 3 watch. So we will be answering those. What we thought we would do though is, a good couple of weeks ago, we gave the media a kind of under NDA presentation about all of this technology. So we're going to give you a kind of slimmed down version of that to give you a good background of it, because of course you will have many questions. We thought we will give you a bit of that presentation before we get into the kind of question and answer session. So as you're listening, if any of you have any questions already, or if something comes up during the presentation, please do type them away into the live chat box on YouTube. I will keep an eye on all the questions. I'll mark the interesting ones and the relevant ones. So no questions about what's the name of your pet dog. It has to be questions about MicroReg. It has to be questions about the watch. We of course, we can answer other questions if we have time as well, but let's keep it all friendly. So really, obviously, Quest Zero is the name of this larger project, and you'll see through this presentation, basically, what it's all about. So if Andy can move to the next slide for me. This is international slide changing. They're in Switzerland, I'm in Glasgow.
Crazy, yeah?
So he's moving them along. So,
and by the way, please forgive me when we have some technical problems today, in case that should happen, because I have a brand new computer, which Marcus gave me, and everything is set up new. Sound obviously is good, so we hope everything goes well.
Absolutely. So we have Francesco here from Miniswys, and he's going to be giving you a little bit of a background of Miniswys as a company, who they are, where they've come from, and of course what they do, and most importantly what their technology is bringing to this whole project. And of course we've got Andy and myself from Horage, and this project very much is a coming together of the minds of these two businesses. So on to the next slide, Andy. We're over onto the next slide. So really you'll see that this project is called, or the watch is called, the Revolution. And really the idea behind it is, we feel there's been three kind of significant revolutions, certainly within the modern watchmaking kind of sphere. So really since the 1960s. Obviously the first one wasn't a great one. That was the quartz crisis, but it was a revolution of sorts for sure. It kind of upended the whole Swiss watch industry, caught them off guard, so to speak, and it really very nearly brought the whole industry down and ended it. But through the hard work of individuals, it got itself back on its feet, and mechanical watchmaking in Switzerland was saved. And of course, as we know, has flourished into the industry it is today. So that was really the first revolution.
And who was one of the saviors?
Who was one of the saviors? There was many a savior, but I think... well, Mr. Hayek definitely has something he has to say about helping save it, but there was many others in there as well, and I think Mr. Mock was in there as well.
Correct. Mr.
So
Elmer
we will
Mock,
get to that.
Inventor
We'll get
of
to
this
that name.
watch, and we get to that later, I guess.
And we will get to that name later on for sure.
Okay.
Second revolution, silicon. Obviously a huge leap forward in terms of technological materials being used, efficiencies were gained, better lubrication, better serviceability of watches, and of course chronometry improved as well. I guess slightly controversial in that it's a very high-tech material, not ever seen before in the use of mechanical watches, but I think it's fair to say that today has been fully accepted as part of the ecosystem of a truly mechanical watch. And the next big area that we believe is going to be the third revolution area is to do with the regulation of watches, an area that has forever been one of the more challenging areas of mechanical watches, how to make a mechanical watch as accurate as we can possibly get it. Lots of things, as you'll see in the presentation, have gone into making watches accurate and as accurate they are today, but still there's a few challenges and hurdles, and we believe that our technology is certainly helping to start this third revolution and get us over one of those hurdles. So without further ado, I'm going to keep quiet and I'm going to pass over to Francesco, and he's going to give us all a bit of an overview of Miniswys, what the company is, where they've come from, what they're all about. So without further ado, over to Francesco.
All right, thank you, Dave. Thank you, Andy, for inviting me here and being guest at your live. And thank you for bringing such a cool project to Miniswys. Miniswys is a company that was born here in Biel as well, so we kind of feel connected to Horage because of also the location. So next slide. Correct. I've prepared here for you boiled down explanation of what the Miniswys motor and the Miniswys technology is. And we start by looking at its composition. The Miniswys motor, as we call it, is this small component that you can hold on your fingertip very easily. It's composed by three parts. One in the center is made of metal, usually stainless steel, and is sandwiched between two piezoelectric ceramics. I will discuss more into depth later about what piezoelectricity is, but for now, just keep in mind there's a special material of certain natural materials. Next. So as when I mention motor, you might think of other type of motors that you can find on shelves of many hobby shops, for example. One is the stepper motor, and here on the left we have an example of the commonly used in the watch industry is the lavette type stepper motor, and what is present in the quartz movements. Then we have DC motors, top right, where we see coils of wires wound around a metal core. And there, usually what happens is that the coils get energized with a current that creates a magnetic field. And these magnetic fields interact with these metal cores and with other magnets and generates the motion. Finally, we also have voice coils motors, where instead we have interaction between a magnet and a voice and a coil of wires. And as you can see, our motor is very different from this type of motors, because
it's actually no motor.
I would say it has no competition in its looks, because you would look at it and it would look like any other watch component. It has this part that could be gold plated. It has this articulated and complex geometry that is resembling some of the watch components, and it's extremely small. Here I put the 1 millimeter as a scale. Usually we're 2 or 3 millimeters in the plane, and less than 1 millimeter in the thickness. But how does it work? I have boiled down the motivation of why it works to two factors. One is the mechanical resonance, and this is a natural phenomenon that happens in everyday life. For example, music instruments, most of them rely on resonance of waves to generate different notes that are interpreted by our ear. Another example is instead very well known in the watch industry, the balance air-spring system, where the two bodies, the stiffness and the inertia, are tuned to each other so that it hits a resonance at 3-4 hertz.
3.5 hertz, yeah.
3.5 in Horage, correct. Finally, and these are like it's a fun experiment that everybody of us do every time unconsciously, is when starting the drying cycle of a washing machine, when the speed of the rotation of the basket ramps up from being still to have, let's say, 1,200 cycles a minute, you actually are testing the mechanics of the system. And you might notice sometimes that some noise appears and then it disappears. that means that the resonance of the structure has been passed, and many engineering has been spent on reducing such a resonance.
By the way, Dave, you in your former life, you had a problem with that. The resonance of bicycle disc brakes.
Oh, please don't remind me. Please. No, thank you.
It says the bicycle makes noise. Yeah. How often did you hear that?
Oh, there was, you could hear them coming from about 10 kilometers away.
Yeah, and it comes from an unfortunate combination of shapes and vibrations which make noise, and you can't get rid of it once it is actually in that system.
All right. Resonance. Resonance.
It can drive people crazy. Yeah.
Most of the times is seen badly.
Yeah.
In our case, it's actually why our motor works, and we have mastered how to generate resonant modes.
Yeah.
Exactly. Resonance can be your friend, as it is in the case of this motor that you've designed, or it can definitely be your enemy.
Yeah.
Correct. The second ingredient to our technology is the piezoelectricity, and piezo comes from the ancient Greek for squeeze, press. And with that in mind, you will understand easily what it's this material property. And it's a combination of an electrical charge, a voltage applied to the system, and a deformation. Meaning if you apply an electric charge, the body will deform, or if you deform, then you will statically charge the material. And in everyday use, we have, for example, piezoelectric lighters, where the thumb presses over the piezoelectric element that ignites the gas. Or more commonly, we have even speakers and buzzers in consumer electronics, where the electric signal coming to the piezo gets translated into sound pressures in the air and finally reach the listener ear. And on the right of this slide, we can see actually oscillators, and that's in electronics a very common use of piezoelectricity in order to keep count of computing cycles. Or in the bottom right is the internals of a quartz oscillator in the quartz movements.
There's an interesting question here. Is the piezoelectric material actually a quartz crystal, but you don't want to say the Q word?
I've been saying quartz possibly too often. No. So it's actually the quartz.
So I think we can go to the next slide, because that pretty much explains it. It is definitely not a quartz crystal involved, which is regulating the watch. Definitely not.
No, it's not a quartz crystal in how we understand it in the watch industry. But quartz as a crystal, as a stone you can find in nature, does possess the piezoelectric properties.
Oh, yeah, okay.
Same as other,
correct. Sure.
Same as other materials and the ceramics that we use. But the piezoelectric ceramics we use are actually sintered, so they are made in industrial plants. It's not a natural stone that has been cut to this shape.
Yeah.
But fundamentally, the characteristic is the same, and it's not only for the quartz movements.
So the interesting thing here now is
Yes.
So,
awesome.
In other words, you are actually activating these two plates. And by them being activated through an electric shock, you effectively deform your mechanical design so that it actually is gripping or pushing.
Correct.
And that's what you see here. But what you see here is nanometer level. Yeah?
Correct. So in this case, this animation is amplified by 1,000 times.
Yeah.
And I think here perhaps we can use the tuning fork as an example on the left. That's quite common. You usually hit it, and that would be our electric shock, and then it deforms mechanically, and then that's what we are actually doing. But instead of hitting it with a finger or with another object, we are sending these electrical impulses.
We have a cool thing here.
You want to try?
We don't know if we can do it.
So
But there's an interesting device here, and usually, when you do something like this, then that thing should actually rotate, yeah, and it's actually doing that. And depending on how you actually do that, it turns in one or the other direction. I'm not the expert in that. You need someone else. But that is a very simple tool to figure out this phenomenon. And the problem you had some time ago, because your specialty is FM analysis,
correct.
simulation. We are talking here about nanometer level movements. So filming nanometer mechanical objects was not possible some time ago, is even is still extremely hard to do today. And that is a big problem. Yeah. So we were for a long time, I think when we started, it was kind of in the blind, trying to figure out, does it move that way or does it move that way?
Correct. You mentioned that Miniswys has been created from an idea. Elmar Mock.
Yeah.
He came up with the ultrasonic welding.
Elmar Mock actually was the inventor, one of the inventors of this watch.
Correct.
And he was the one who was responsible for plastic injection. He's a watchmaker, but he was also plastic engineering. And this watch came to life because ultrasonic welding allowed it to actually put the glass together with the case. And in this case, bring the cost so far down. So that was a core technology. People do not know that, but that made this watch possible. And he used vibrations and ultrasonics and resonance in his further work. Correct. Tetra Pak was one thing as far as I know. And one of the ideas was, could we move things by vibrating at the end of the day? And these kind of micro actuators were an idea, and they came into being through him, together with another researcher, I think. And but in the beginning, it was trying.
Correct. It was
just trying.
There was no way of visualizing, no way of simulating it. They were testing different shapes just with a file, changing the shape of the motor and.
So you needed years actually to figure out where it's going and how that works. And then you came in also after a while and made these things visible and thus much more predictable and usable. So it's super fascinating. It's really amazing to think about that you have a flat piece of metal and then you do that.
Actually, the next slide we can see this moving or not moving.
Yeah.
So here, here the video works better. Great. So on the left, we actually see the big oscillations, much amplified, but in the center, actually how it works.
Yeah.
And as you can see, the motor it looks like it's not moving because the amplitudes are 1,000 times smaller than the human hair. And therefore it's
and by the way, we have this real thing here. Yeah? I'm just switching in a different view to see. So when we talk, because there's a question about do we have a prototype of the K2 movement. So we have been going through what you call proof of concept first. We met each other, we talked about it, then I said, can we solve that problem? Can we move a certain thing in a certain way? And said, probably yes. Yeah. Then we built a proof of concept, what you call it. So that is what you see here. This was a proof of concept that, okay, in this scale, at that force, you can move that. We are not talking research anymore. We are talking engineering. So that is a proven concept. Then second thing was proof of application. Can we arrange it in a way that we effectively can adjust this spring length by moving something? That was a proof of application, and that is really here, under my finger is here. So just So I'm real here. That is not some movie or something. But this is a movement underneath that is built on top of that movement. Yeah, that was the proof of application. Yes, We can move that thing back and forth. But of course, you can't build it like that. That's what you don't do. But all the components involved are in real size, especially the most important component, which is the index, the thing where you see actually the spring, this one, and the motor on the other side in its correct size. That's a very small motor. You need to, that's a plier, So we are talking about something very small. And this thing, so we saw, okay, we know how to do that. So does that fit into the movement, into the existing movement without having to change anything in scale? That was the most unknown question, but with 3D modeling, and we are pretty good in that, we of course know one shape. So here, then you can see effectively the movement as we have it today. And we then rearranged what you see here as a proof of application into a prototypable product. So, and then we just take away one piece here, and then you will see that little motor, which I showed you. Need to change, present. So now you see actually, this is our movement as it is today. And you will see here, this is the motor you have seen in reality, just moving something linear. And instead of doing that linear, we are moving a screw. That screw, by the way, is also not new. There has been screws in the past. And this is how we now prototype the next stage, but that is already built in. We can predict that it will work, It is moving the other thing, so it will move that. There's no difference. It's just packaging into a product now, and that's what we are doing the next couple of weeks and months, and then making sure that the parts are in position and so on and so on. There was another question. Do we collect the questions, Dave? Or?
Yeah, we're doing the questions at the end, Andy. So before we let time run away with us and we run out of time.
You are the boss.
Yeah, so where were you at in your presentation there, Francesco?
Push frequency, so we just do proof of application.
Correct. And what's important here is that the motor can hold the position in along this stroke. Yeah. And it can keep that position without requiring any energy. Or
and you see on battery. The right here, there's three different positions, and that is exactly what we want. Any other motor needs effectively energy to hold.
Correct.
This motor is dead when it doesn't have energy, and that's why it's holding. It's actually gripping by
friction.
So, and that's the unique property. Without that, you can't build this kind of stuff. No. Good.
Then just quickly,
a good way to maybe think of this is very similar to a screw. A screw is effectively held in position by friction, and if you're adjusting the screws, say on a balance wheel, it's the friction of those screws in the balance wheel that hold them in position. This is similar, except that instead of using a screwdriver to turn it to adjust position, by this one you can apply an external power source, which will allow it to be moved. But once you remove the power source, like removing the screwdriver, it stays in that position.
Correct. Perfect analogy.
Good. So we have a lot of advantages at the end of the day. I think
few advantages: precision, low voltage, no magnetic fields, and no power consumption.
And precision, we say you're moving things in the sub-micron level.
Correct.
It's barely seeable with the eye. And that's what we want to have in movement, because when we want to regulate to very precise standards, the hand is not as precise as it should be. But we will have some more slides on that. Okay, so we move on.
We should move on.
We've been talking.
Finally, I want to just highlight a few of the characteristics of our technology that made us believe from the very beginning that this project was a perfect technological fit. It's the vibration resistance. We can resist shocks and vibrations at the wrist of the user. The submicro precision, as already discussed. The very small footprint, particularly the flatness of our motor, that allows Marcus to integrate in the existing movement without completely redesign. And finally, the aesthetics, as we talked at the very beginning, it doesn't look like a motor. Because there are other solutions on the market that we might be talking about later, where instead you have some coils, you have magnets.
And all that we don't want.
And then
You know, the traditional crowd of mechanical watchmaking doesn't want to have coils and stuff like that and magnets. We want mechanical stuff.
Exactly.
And that's
the beauty.
These are two actually mechanical pieces of material. They have no electronics inside, no nothing. Okay? Yeah,
Good.
cool.
So now we're going to move on to Andy, who's
There
going
has
to give
been
us a
questions
little-
already, chronometer certification, so it's my turf here.
So, Andy, let's have a quick run through about the ideas of precision and why precision is not always what people think it is.
Yeah. So we have these quality seals, call them quality seals. They are very important for the Swiss watch industry, and they are necessary, in my opinion, to force a company to produce high quality parts, because otherwise you don't pass such kind of, let's say, quality assurance, which COSC, chronometer certification, METAS, Geneva seal, all of them actually require a certain precision of the watch. And if you do not produce parts in a certain precision, then you will not pass any of them. It has nothing to do with our work from that perspective. But yes, we get a precise watch out of a chronometer certification, but does it really say the watch then afterwards, when it's owned by someone, is precise? And does it solve the real precision problem? And I would say no. It is important, but it is not, it is half the story only. So why is it only half the story? What is the real problem? We have seen before, we talked about precision of parts manufacturing. Today we have machines who can produce extraordinary good parts, CNC machines, computer-aided programming, and so on and so on. All of this is relevant in order to make very good parts, which are relevant to make first and foremost a very precise in itself product, high quality precision. So this will be unchanged. There is no good enough part in mechanical watchmaking. The best part is the one with the slimmest tolerances, but it has limits because of cost and so on and so on. So we need to find this middle ground here. Then we have initial regulation. Initial regulation means you produce a part, then you put it together in a movement, then you actually start regulating it, and then you regulate it for either the standard, which is most very often ±6 or ±12, or when you go more outside of Switzerland, ±30. So the watch somehow moves within a certain window, or you need to do that for COSC certification chronometer, and that means -4 +6. And there are some other restrictions, and you test that over 15 days. So, but what you have is effectively a lab precision, because the behavior of the wearer has a significant influence on the precision of the watch. People do not know that. They actually buy a watch, go from a retailer, get their nice Rolex, put it on the wrist, and then they're surprised because they are doing all the day an Ironman with it or whatever, a certain behavior, and the watch is not running in that window which they expected. And it's neither the fault of Rolex nor the fault of the person. It's the nature of the problem that we regulate a product in a lab environment, but we use it in a live environment. And that is an unsolved problem. And to that, you have temperature differences, altimeter differences, shock impacts, anything actually influences the watch. Why is that? So effectively, you get a watch. We might say, okay, it's perfectly regulated in the lab environment, but then you start moving and then you actually lift or decrease the average run rate of the watch. That is the reality of mechanical watchmaking. There is, and it's always, this problem exists since the existence of Swiss watches. And these influences of the wearer cannot really be predicted by anybody. It's wearer specific. Only the wearer itself can actually figure out the precision of his own personal watch by wearing it and by comparing two time intervals, namely in the beginning of the week and at the end of the week. And then you see if it's 10, 15, 20, or 5 days, let's say 6 seconds means 30 seconds faster. And that's what you want to correct. That's what we want to bring back to adjust it to the wearer. It has nothing to do with the precision itself. Perceived precision is the topic. So let's go a little bit in the theory, because I think it's important that people understand also what is the theory behind it. There are two ways of regulating watch. One is screw type, so you change the inertia of the balance wheel, the spring is fixed, and then by moving the screw out and in, it will be more inert or less inert, it will move faster or slower the watch. Just to give an idea what it means, to change 1 second on a watch, it means you turn one screw 3.6 degrees by hand, and that screw is damn small. It is a very, very small screw. When people come here, they will see it. And because one turn of such a screw means 25 seconds change, since you can't only turn one because it needs to be balanced, like in a car, you know, the wheel doesn't want to have unroundness, and you need to do 2. So one turn means 50 seconds, and this you divide by 360 degrees. So it's a very sensitive thing. Smallest impact, smallest influence has influence on the precision. And the closer you go to 0, the more expensive this work is going to get. So second, other way of doing it, you change the inertia of the wheel is the same, and you change the length of the spring, the effective length of the spring. It's called the index adjustment. We assume, we do not even know exactly, because it's hard to measure, that 0.01 millimeter in length changes actually 1 second. So that is not very much. To move hundreds of a millimeter by hand needs very good watchmakers, and that's why these regulation watchmakers have been and always are always sought after, because still the fine-tuning is done by hand. Yeah, that's pretty much the challenging part of the whole thing. So what we actually now do, our solution was, we kind of want to use an electric shock to activate someone in this watch. Homer Simpson, you need to think about it like the defibrillator thing. You're starting something inside of that watch which is dead and sleeping when it doesn't get any shock. And then when it gets this shock, we control this shock, we give it actually a pattern. This electric shock has a pattern, hertz rate, and so on, in order to move something. In our case, we want to move this index adjuster. And that's what we have done. So we are hiding the sleeping watchmaker inside of that watch. Everything is traditional. There is no unknown here. We are redesigning this index unit in order to get rid of play and all this kind of stuff. And in contrast to have what you have seen before, I'm quickly switching, Dave.
Yep.
Top. And what you have seen here was that there was no screw. That was a direct transmission. That was our proof of application. So you see, effectively, you can see here that we are moving linear, and we are then moving that way. And that's obviously, we didn't want to have that, so we wanted to have something which is impact proof, which is, by the way, also for standard movements today a problem, that they are not so impact resistant. When the index adjuster gets a hit, it can move. With this new design, we are also tackling that problem, because we changed, we are this kind of thing here, this needle will be moved back and forth here, yeah? And this part is rotating, and there is a thread underneath. That means, probably we talked about 1:30 reduction gear ratio. So we are further reducing the movement of the motor and the forces, increasing the forces by 30, by the factor of 30, just by a mechanical arrangement of kind of a warm gear. Yeah. And so all that, what we know, is a combination of things we know how to produce and things we know how they will work. And that gives us this innovation, which is, yeah, cutting edge, I would say. And we can see it here in the next slide. So when watch comes out of the lab, customer starts to move, will see, then you start actually do that for a while and you get a feeling for your watch, and then you will use this device, which we did not talk yet about, will come later. And we are, by putting shocks through the system, we are moving that needle. Yeah. So you can see that here. And then you're bringing back this average back down. See it here. So I'm moving that a little bit by hand here. Yeah. You see it? Now people can see that. That's it. It's so that simple, unbelievable. I'm fascinated by myself. The best things are the simple ones, you know.
Yep, a simple idea, but as always with some simple ideas, not quite as simple as it would like to be implemented in the real world. But that's where we have partners like Miniswys coming into the fray to help us bring this to reality. And
what you see here, these two slides are actually the ones which you saw already under the microscope. So that is real. It's not some CGI fake Photoshop exercise or whatever. It's real stuff. Yeah. How many questions? We have questions here. Actually.
We have questions. So what we'll do is we will quickly maybe go through the product that we're now bringing to market that's going to incorporate this technology. So this will be the first watch in the world. So it's my turn. So, introducing the Revolution 3 MicroReg watch. Maybe not the most original name, but we thought it's the third revolution and it incorporates MicroReg. So there we have the name of the watch. So if you can move on there, Andy. There's a little film, I think, coming up next. If I am
Asa is talking about his 30-20 movement. Isn't that a Rolex?
It could be. So Andy, if you can flip on to the next slide for me.
We're playing that, or?
There we go. Yep, just to let people see, there's a quick little 1 minute film that you can quickly watch here.
That's the one which we have been doing.
Yes.
Dramatic. It's all sound thing. Pretty damn good animation.
Indeed it is.
Good. You tell me when I need to shift the slides.
End of this. Yes, this will just come to the end shortly, near the end.
You are looking in the wrong, Dave, you need to look on our screen. We are already further.
Yeah.
You're looking on YouTube Live.
I know, I'm with. Oh, that's why. I always forget about this delay. So yeah, this is the joy of lives. You have too many screens open, and I have too many screens and too many things to look at. So we are now, let's see which slide you're on, Andy, because I actually can't see it. It's so small.
Why can't you see that? Okay.
It's not showing up.
This one.
Next one. Okay. No,
but you see the Skype window, yeah?
Yeah, but it's not showing. It's so small. Sorry, everybody.
You need a bigger screen. I'm sorry.
I have plenty. Yeah, my screen. Let me just get it bigger. Okay, so if you can move on to the first one of the watch there, Andy, for me.
Yeah, this one.
For some reason, it's completely lagging at both ends for me now.
Are you sure you're looking at the same thing?
Yep, I'm looking at the Skype screen and it's not updating at all.
Shall I stop screen sharing quickly and then we try it again?
If you don't mind.
Yeah, we are live. I mean, please forgive us. Confirm, stop sharing. I probably just share the window now. That's also possible. Huh? Then you don't see the screen, but you actually see what I am showing. Now you should see it bigger.
There we go. So
you know the screen anyhow.
Let me make it bigger on my side. Yeah, I need to go here. So what we're introducing is we believe to be the first Swiss mechanical watch on the market that can be externally adjusted to the wearing profile of its owner or the person wearing that watch. So we can move on to the next slide, Andy.
Yeah. There's an interesting question from Lemwick.
So in terms of the watch, we have a time-telling disc on the front, and there's definitely been some questions about the time-telling disc, so we will definitely get to those questions later on in the presentation. And on the case back, you have a second time display, which allows you to have a very accurate to the second time telling. You have the hours, the minutes, and the seconds. So if you can move on again.
Shall we quickly say why we did that?
You can go into that now if you wish, yes.
I mean, some people said, are you stupid? You're making a very precise watch and actually show in minute increments the precision. But that is not the point, I think. The point is we had a long discussion about this whole layout of the watch. People, because our movement is so beautiful, have always asked us, can you make a watch where you show the movement to the front? And we didn't see real reasons to do that until we started to work together. We have been working on the whole regulation idea for a long time. Then it was materials, and that is such a revolutionary idea. This is effectively the launch product we can make out of it. For us, it's a launch vehicle. It is something which I hope probably in 10, 20, 30, 50 years, people will look back and say, that was the watch where we started this. And this, of course, there will be other watches down the road, which regular layout and all these kind of things. But we thought we needed, that's a marketing thing, yeah, at the end of the day. And we are not known for ultimate marketing fluff, but sometimes you also need to think about, okay, how do we stand out? And that one is effectively standing out because we are putting the technology in the front, we are putting our movement capabilities into the front, and you can read the time properly, but perhaps not in the seconds. But that's also not the main purpose behind that, because this we can leave to other watches, hopefully thousands of watches to come.
Absolutely. I think possibly there's sometimes some confusion between the difference of an instrument operating very precisely, but having to use that precisely in a different way. If a watch is running very precisely and is hitting the hour marker exactly on the hour, then you can argue you have a very accurate watch. Most people, I would say, day to day, aren't timing things to the precise second. You know, most people have a quick glance at their watch to make sure that they are in and around the time they believe it to be. And one of the other big things about this watch is people have often asked us to invert the movement. So many people look at our watches, whether it's the Superseeds or the Lensmans, for example, and they turn it over and they say, if only the movement could be in the front. And that was something that had also been in our heads for quite a while now. And this felt like the perfect watch to do that with, because it lets us also expose the movement and the technology in full display. So it really is a kind of conceptual watch. It's the Founders Edition to really bring this technology to the fore. Will we incorporate this technology in, I guess, more conventional watches in the future? I am absolutely sure we will. And we will have potentially watches that if people want something that's to the precision and they can tell it from the front of the watch, that will be on the cards as well. You'll notice
how do we handle actually all our questions? You have under control, or do we go
I have it. Yeah,
afterwards?
We're good.
Because we have a lot of interesting
we have a lot of questions. So the movement color we're calling peacock blue. Why peacock blue? Well, because the movement, I guess, is on the front on display, and I guess, for want of a better phrase, it's showing off to the world what it is, very much like a peacock when it decides to show itself off, and it has its blue-green plumage on display.
And we have done that already, yeah? We have done this already. I didn't find the sample today. It was somewhere hidden in Cedric's dungeons.
Absolutely, but we do have a sample movement with
and it
this
shimmers
color.
A little bit, you know, it has some kind of blue
iridescence.
Time for the next.
It's kind of iridescent between the blue and green, but yes, very good in terms of colorway.
Love it.
So if we move on to the next one, Andy.
Yeah.
So obviously the adjustment tool, and there's definitely questions about this. So in effect, you will have an adjustment tool. You simply sit the watch into the cradle of the adjustment tool. That will activate the sleeping watchmaker within the watch, which in turn will allow small incremental positive or negative adjustments to be made to the regulation and the timekeeping of the watch. This is something as a tool that will be able to be used as a standalone tool, just making little adjustments based on what you perceive you need to do. Or there's going to be an ecosystem that will allow you to plug this into a device, your phone, a tablet, for example, and will allow you to utilize more data in order to really hone down that regulation depending on the activity that you plan to do. If you can move on to the next slide for me, Andy.
Yeah.
This is showing an idea here. So we have the mechanical regulator, which is obviously on the watch. Now, this is a big point to make. The watch itself is still very much a mechanical watch. It still features a fully functioning mechanical regulation system. There's many other systems in the market that have tried to resolve this issue, albeit in different ways. Spring Drive from Grand Seiko being a good example. But in that system, they've completely replaced the mechanical regulation system with a very precise, it has to say, quartz-based regulation system. Now that takes away from the purity of a mechanical watch, letting it fall more into the mechanical hybrid type category. But we still have a fully functioning regulation system. So much so.
That was, by the way, a question before.
Yep,
would we completely remove that? To be honest, I have been always looking at high beat and all kind of things, but the fascination of a mechanical watch is exactly that. It is exactly this balance wheel swinging 300 degrees back and forth. This is this magic thing, and that what makes these watches so fascinating. That's why we want to see the movement in the back through the case back, but in that case we see it in the front also. And so I believe everybody who is trying to get rid of that, except Spring Drive. I think Spring Drive was a very successful product for Seiko, but they changed the nature of the Swiss mechanical watch. And I would say if we completely fail, if I'm completely wrong with what I'm assuming with the success of that, then at least we will probably succeed at the scale of Seiko with Spring Drive, which, by the way, is big enough. So that would be the lowest I'm shooting for.
Absolutely. So as I say, this is a truly mechanical system, but obviously inside we have our what we are internally calling a sleeping watchmaker. So you have a watchmaker effectively living inside your watch, fast asleep, doing absolutely nothing. The watch runs like a pure traditional mechanical watch. But when you want to make those little adjustments, when you want to personalize your regulation to what you wish to do, you can wake up this internal watchmaker with the tool and then make those small adjustments. Obviously, lots of developments and applications that we can build into this using information of technology, cloud-based computing, apps, etc., that will allow more interaction with your purely mechanical watch. So if you could move on to the next slide for me.
Yeah.
So this is our timeline. We announced to the press a few weeks back, and obviously, as you will all know, around on the 24th of July, we introduced this technology to the wider world. We're currently obviously producing and working through the system. We've opened up orders for this watch, and we're moving through the technical de-risking and prototyping phase. Obviously, all of the proof of concepts and proof of applications have been done. So we're bringing this to the market at a point where we believe and we are very confident that other than the hard work ahead of us to get this into the final product, we just need to work through those annoying little gremlins that always crop up, and we work through all of these things, Marcus and the engineering team making everything come together. We obviously then start the production of the standard part, should we say, for the watch. The movement itself is broadly all the same parts that are used in a K2 movement that you will know from watches that we already produce. Very few parts have had to be changed, and of course including the extra parts for the MicroReg technology. And then with a shipping date that we're aiming to ship within around 24 months. Now, obviously, that may come forward a little bit. It may get a little bit better, the timeline, but we want to make sure that we don't overpromise in terms of deliveries, and we want to make sure that we give the engineers and watchmakers plenty of time to get everything absolutely perfect on this. And that is on to the next slide, Andy. The watch itself, obviously, much more information available on the website, obviously at horage.com. But broadly speaking, we have a stainless steel case, dimensionally 41mm by 10mm. We are known for producing thin watches, and I think the 10mm size in this proves that the MicroReg technology is not adding any height or size to this watch. 100 meters of water resistance, you have the 72 hours of power reserve from that K2 movement, and obviously it's still running at that 3.5 hertz as the K2 movement does.
And if we wouldn't tell the people that there's inside, they probably wouldn't even recognize it.
Absolutely, for sure, someone could potentially buy this watch, not have the tool, and never use the tool and operate it like a completely normal mechanical watch if they so wished. If you can move on to the next slide, Andy, for me. So obviously we released on the 24th of July. We are opening orders initially for a period of 2 months, and so until the end of September. Deliveries commencing in 24 months. And we have a special founder pricing category, which is 3,900 Swiss francs. Now this price point is to take into account that anyone who is joining us along in this project and committing to one of these watches does, and we understand and appreciate, have a long wait ahead of them. We have had many people already who have joined the program and have said that they really are praying and hoping the next 2 years move quickly for them.
And we would
the
do
final
anything to
price
do
of
that.
this, absolutely. The final price of this watch in terms of a retail price point will be around the 6,900 Swiss franc price point, which puts it very much in the range of our existing K2 equipped models, such as the Super C GMT at 6,500. That is showing that this technology is not adding a huge price premium to these models. But anyone who is committing to the project at this point is getting an exceptionally strong value proposition in this watch at 3,900.
That's why it's called Founders Edition, yeah?
Absolutely, because you're helping to found this technology. Now, after the 2 months, we will close the pre-orders. We will likely open the pre-orders again at a point in the future. So anyone who is maybe unsure or maybe wants to be a little hesitant and wants to see how the project develops, for sure you will be able to join the project at a slightly later point, albeit maybe not at this low an entry price point. So anyone who is loving the idea of this and likes this price point, the next 2 months is your time to make the decision. We're also offering a founder supporter voucher as well. So people who maybe like the idea and want to support the technology, but maybe aren't in the place to buy a watch at this point, are able to buy credit vouchers for Horage at a price of 150 Swiss francs. But for each 150 you spend, you get a voucher for 300 Swiss francs. You can buy a maximum of 5 of these, which would cost you 750 Swiss francs and would obviously get you a credit note for 1,500. That can be spent on pretty much anything that we produce: straps, books, and of course our other watches. There's only 2 things you cannot buy with the vouchers. You cannot buy other vouchers with the voucher, and you cannot, because that would be a way of making good money. We got wise to that one. Also, what you cannot do is, unfortunately, you cannot buy the Founders Edition watch with the vouchers because we have already priced it at such an aggressive price point. But outside of those 2 exceptions, you're able to use your vouchers to buy anything that we sell in the range at the moment. And if we move on to the next tier for me there, Andy, the next slide. These are the main points I think that we would like to get across in terms of this watch. It completely maintains, I think I can't see the top part of that, Andy.
It maintains the essence of a mechanical watch.
Let me just, there we go, come down. So it is completely maintaining the essence of a mechanical watch. If you'd never wanted to use the tool, if you never wanted to activate the MicroReg technology, you could operate the watch like a completely normal mechanical watch. In fact, so much so that a watchmaker can open this watch up and regulate it by hand if they so wish. Of course, that means that you won't get the advantage of that personalized regulation. This is not a replacement. So something like quartz or something like spring drive is a replacement technology to replace an area of mechanical watchmaking. And in many cases, it leads to an excellent outcome, but it does detract from the nature of a mechanical watch. And importantly, there is no technological obsolescence with this. It's not a system that eventually will wear out or break and make the watch unusable. In terms of servicing, in terms of use of the watch, everything is exactly what you would expect and love from your mechanical watches. So if we move on to the next slide, Andy, I think that's
Questions.
us towards the end. We're on to question time.
And we have a
So
ton of
I am going to pose the questions. I'm going to be the show host that poses the questions, and we will point them either towards Andy or to Francesco. So first question we have is it possible to have an idea of how accurate this system can be? And that comes from Fernando.
I would say, according to, because there's another experience down there in the comment section where Scott, I think, said, Larry Scott said, I track my watch 2 to 3 times a week, caliber 1570, it's my daily, and that returns 1 second per day. But the time grapher shows 5 to 10 per day. And here, welcome in the problem. The time grapher actually is showing a static situation measured in one point of time, but the day consists of time distance, and it will be up to the person using the tool to bring it close to zero or at zero. That is very likely. Of course, when you need to consider now, okay, this week I'm actively working out all the time in the gym, and in the following week I'm probably just sitting at the desk. There will be probably some difference, but that's something you need to find out. Practically, the person is in charge of the accuracy.
There might be some profiles that the user can set
probably
depending on whether it's on holiday or not.
Yeah, that's what we probably find out in future when the people are willing to share their experience with us, that we probably can detect also profiles and then advise people what to do. There was so
Absolutely.
accurate.
So they are
The motor itself can adjust in sub-micron level, which is very hard to do by hand. So we are operating more precisely than someone is doing it by hand.
So hopefully that answers that one.
Yeah.
Another question we've got, what colours will follow? Is peacock blue the only choice? I can answer that one at this point in time. Peacock blue is your only option in colour. Will we produce different colours once the Founder edition has been issued? I'm sure we will look at potentially other colours, but that is definitely a question for the future. But as it stands with the Founder edition, we will only be producing, there's a tongue twister for you, the one colour that's peacock blue. Another question that Arthur asks, but many folk have asked this, reverse anyone, can we make the lugs flippable? This is the point where Sue probably is going to start shouting at me if I bring this question up. But Andy, maybe you can answer this one because I don't need to take the heat.
We have a lot of challenges involved in making that watch with less movement, and our philosophy is, first and foremost, there must be also a very wearable product which fits into a good look. We are not in a position at the moment to also design a good-looking, slim, well-working, flippable case luck construction. So I think that's something we should not touch right now. So we needed to decide for either or the other side. Probably we leave that to Jaeger LeCoultre because they have a watch called Reverso, and that would obviously be a candidate. But we can't just take their idea and build on that. Probably they are coming to us and want to make a joint venture. Who knows? But
So
it sounds easy, make it flippable, but then executing it in a design and a technical way needs a lot of time until that works, and that would be too risky for us.
I think it's fair to say to execute it in a way that would still allow for a good looking and wearable watch is very difficult. We could put straight lugs on it and you could just flip it over, but it would probably be a very uncomfortable watch. And as we all know, uncomfortable watches don't tend to get much wrist time.
Nope.
So a question now for Francesco. Piezo has a lot of upsides, downsides being limited range, high voltage usage, which should not be a problem here. But what about temperature sensitivity and degradation due to mechanical stress?
That's quite a technical questions. Nice to see them. So first of all, temperature dependency, I believe any part in the mechanical watch is affected by that. So similarly, it will also be our actuator here. And more specifically being somehow a closed loop system, meaning there will be some kind of sensor that could just be the user with a time graphing app, for example. We will be able to correct for those variations if there would be. So it is robust and the technology is redundant. In terms of voltages, our technology, because it's resonant, does not use the usually high voltages used in piezoelectric, other piezoelectric actuations. And yeah, believe that might answer the question.
By the way, playing around with that.
Great.
And people, I mean, I'm pressing buttons and it's moving. You just barely see it. Yes.
There we go. Thank you for that, Francesco. What else? A question is, why don't we just use wheels, gears, and connect to an external screw or crown to achieve the same? Now, I think my answer to that would be that obviously you then need to have another point of entry or an opening in the case, which is never a great idea, where you want to minimize the number of openings if you can in a case, obviously for things like water resistance, etc. And also the finesse and the amount of adjustment would still be relying on the human hand. And as we've discussed, I think through the presentation, the finite amount of infinitely small adjustment able to be done by this MicroReg motor compared to hand is a very different level of accuracy.
And a number of screws, a number of screws in line of each other, or linear, and pins and rods and seals makes tolerance stack-ups, and that's when you actually operate the crown in a watch. You will have a lot of play, and that's exactly what we don't have, especially the bridging the gap between the case and the movement is the most critical part, and we do not want to have play, and we do not have high tolerance windows. So that is why there have been in the past, also in the present, attempts to try to do that, but it comes with a lot of cost, with a lot of tolerance, and with all kinds of problems, and that's why it never succeeded. Because it delivered the accuracy you wanted to have it. We can put another question into that, because there was, which relies to that at the end. And it said, have you considered if the motor will need to be homed or how it will know when it's moved its maximum distance in any direction? Foolproofness is the key point. We have a mechanical end block, and when you hit the button 500,000 times, it will not go further. So you will actually be in a window. And since you can always adjust it, you just need to start tracking again the time and figure out where you are. But we will, of course, limit that to a certain window so that nothing can go really wrong. Otherwise, we would have to put a sensor in there, and that's what we don't want. Okay?
Yes, very much. We want to avoid having any form of electronics, power source, or wiring inside the watch to keep the watch purely mechanical inside the watch itself. Another question for Francesco, which is, this is from Mike Armstrong. He's enjoying the presentation. He's liking seeing the mechanism in detail. How much torque can a motor like this output?
Usually we talk about force in our case, because differently from other motors like DC or stepper, we are by nature linear, kind of as you can see now on the screen. And so in terms of forces, we are around, with the 5 volts that we're using here, around 30, 40, 50 millinewton, meaning lifting 5 grams of weight. then our technology can be distributed in space so that you actually get out of torque. But then it will depend on how far from the center axis you place the motor, so it will depend on the actual geometry constraints of the application.
Quite a lot.
For the size, the
And
power
everything is
density is for power density is quite impressive.
And there was another question which I think you jumped, Dave. Michael Brown. How will MicroReg further improve the long-term sustainability and accuracy of certified chronometers? Yeah, that's actually the target. We do not get rid of chronometry and chronometer certification, not at all. We had a very interesting guest recently from COSC certification, and he was very fascinated by this because it opens also more possibilities for chronometer certification. For example, doing chronometer certification on a closed case basis, because that is actually a real problem. When you do something like meters and the watch is really off out of whatever reason, you need to actually open it in order to probably just fine-tune half a second. And then you can imagine what that advantage could be, that we are testing in future closed watches as they should be in a chronometer certification laboratory, and then can do these final tweaks which are necessary to be in that window. So yes, I would say definitely our technology helps to make this whole chronometer certification exercise more effective, more efficient, more cost efficient, and that's ultimately good for everybody.
Absolutely. Now, I've also got a few questions that we pulled out of various forums on the forum on our own website and a couple of the other areas. I think we've actually managed to answer the majority of those as well from questions that we've had in the live. A couple of questions that have come up, though, that are not in the live questions are prototypes to go on tour to regions. The answer will be yes. When we have prototypes, we will definitely have them out on the road, letting people see them and getting an idea of what the watch itself is all about. So that is definitely something for the future. And one for Andy, is this new IP or repurposing and refinement of an existing IP? Andy, you like your IP, so what's the answer to that one?
The depths of IP. Everything in the world has been some kind of invented, more or less. And IP is, in most cases, a good combination of new ideas and existing solutions when it comes to producibility of products. That is most of the time the showstopper for any new idea, for any invention. Then I would say, okay, your IP is, since the past 15 years, how to make, produce, control such a motor. There's no unknown, so that is a good thing. Of course, control algorithms and nitty-gritty details is called a trade secret. Yeah, that's what we don't tell everybody. But at the end of the day, yes, we have a motor IP which is solid and which we understand very well. Then we have the whole regulation arrangement and the way you actually deal with this whole product with the 2 timestamps. So we have patented, of course. We have filed for patent protection. I've lost my 3D file here. And this patent protection, we will see how it plays out. I mean, patents are around and they will be modified over time. They will be extended. We will find new things, add information. But I think the most important part is our IP, which is in our heads and which is our knowledge about that. And there we can say these parts which are involved in this product, they are very well known to us. Yeah, we have a very solid understanding of all the parts which need to be manufactured. For example, the screw. These kind of things have been made, similar things have been made in the past. So I would say from manufacturing point of view, the IP is known and understandable. From a arrangement of the whole idea of the whole system, that is completely new. Nobody has done that as far as we can see today. Many people have tried something like this, but they didn't have this combination of technologies and know-how available in their company, or probably in the company, I guess. So I would say this is unique IP, and this unique IP allows us to kind of be unique in that. Yeah, I don't think that there's anything comparable.
So hopefully that answers that one. I put up a last chance for questions because we've managed to run well over our hour, but we want to make sure that we got all the questions answered. So the couple have come through here. Service support by AD only or support for independent watchmen? The idea on this is obviously, as Horage, we can bring watches back to Biel to be serviced by the watchmakers that have designed and built them, but we are always open to working with independent watchmakers who may want to become interested in helping work and service on our movements. We have a number of independent watchmakers around the world, in the UK, in the US, in China, in Taiwan, who are able to work on our movements. So we don't see this being any different. Obviously, sometimes there are specialist tools needed, but we will absolutely be open to having conversations with independents that would like to be able to service our movements. We have visitors in at our atelier regularly who are asking all sorts of questions. So if you're a watchmaker and you get to Biel and you want to come and see us and have a chat, you are always more than welcome.
Yeah.
I see one final question before we round out this live from Mike Armstrong. Here's a technical one for you, which is, have you thought about UCM keyless works?
UCM keyless works?
I think you would probably need to get our watchmakers in to ask that, but I'm not sure. I am not technical enough to deal with that one.
Me neither.
So
Same.
we will get back to you on that question.
We will
find one of the
time.
watchmakers to see what their answer on that is. Final one popped up. Backwoods has said, will you be sharing more photos of the actual looks of the Autark tourbillon and all dial movement color options soon? The answer to that is yes. We have just got some of our first coloured bridges for the movements, and they will be on display over the next couple of weeks. I think we are waiting on the final one. We have the black dial, we have the blue dial, we have the grey dial. We're waiting on the salmon dial coming through, but I believe that in the next couple of weeks we will have all of the dials and all of the movement colours to show you. We've also now received final cases and bracelets. So again, we are getting very close to the Autark tourbillon project beginning to deliver its first watches. Originally, we had scheduled for Q1, Q2 of 2025, but fingers crossed, we are looking quite good that we may start the deliveries at the very end of this year. So more news to come on that. If you're a customer of the Autark tourbillon project, you will be receiving an update as to when we will be doing a live with all of the information on those areas. So anything else, Andy or Francesco, you would like to bring up before we bring this live to an end?
I'm fascinated how that the whole thing fits into there, because I'm operating the 3D file here. It's still a little bit delayed, I guess. But it's a very, very slim and nice design made possible by 20 years of research and work on your side, 15 years of work on our side with making movements. So I think that is something very, very special, which is definitely worth to participate and see how it plays out. And I'm sure it will play out in the way we hope it is, that we make a difference in the watchmaking world. And hopefully a lot of people will support us doing that, because it's worth it. It will make nicer watches.
Absolutely. And of course, if any of you have any questions that either you were too shy to ask or we haven't answered or you need more information, please do either go to the website and you'll find the forum in the community section, and there's a Quest to Zero section. Feel free to ask questions there. Or if you would like a more personal or a more private answer, please do drop us an email at lostintime@horage.com and one of us will get back to you with the details that you are looking for. So thank you very much for joining us, Francesco, and hopefully giving the watch in public a bit of an insight as to Miniswys and what you do and the motor itself, and of course Andy for giving us all the details and backgrounds on the project. This video will be up on YouTube to be watched again. It might take a few minutes to render and get itself up there, but you'll be able to watch this back if you missed anything. And as I say, if anyone has any questions, please do reach out to us. So thank you very much for being part of the audience, and thank you very much for asking all the questions. And we will see you again soon. So it's a goodbye from me.
Back into the guest mode here. So we see you beautifully in Glasgow. So then I'm getting out here, I guess.
Great. Thank you very much.
Thank you again.
Thank you.
Bye.
Thank you for having me. Bye.